Hello guys, so now we'll be solving the DP problems live. So in case you guys have any questions that you want me to solve, you can share the link. Meanwhile, I'll be solving the CSCS DP problems. So yeah, so I've just completed this problem, edit distance. So let's go to the next problem. Longest common subsequence. Okay. Just a minute. Yeah. Here, just 1 minute, guys. Yeah. Uh, I hope you can hear me. Hello. Yeah. So this is the problem. Let's open the center. I What is the problem statement? Given two arrays of integers, find their longest common subsequence. Okay. Subsequence is a sequence of array elements from left to right that can contain gaps. Okay, okay. So we have to find the longest common subsequence in the given elements. Okay. Uh, what are the constraints? Array sizes are 1000 and the array elements can be 10 power 9. Okay. So what can be the expected time complexity here? Okay. Yeah. N and M lies between this. So the time limit that we were given is 1 second, right? So in 1 second, we can do roughly 10 power 8 operations. So we can do a solution with time complexity big of n square log n as well, right? N square big of n, all these works. So we had to find the longest common subsequence. This is a standard DP problem, longest common subsequence. But yeah, I've heard about this problem and solved this before once during my semester when I was doing DA, design and analysis of algorithms. But yeah, I've never really solved it by myself. So this is the first time I'm solving. So let's see the problem. So the problem, let's take an example. Okay, the example, let's go for 8, 6, okay. 31327482. 31327482 and 651234. 651234. We have to find the longest common subsequence. So 1, 2, 4. This is the longest that I can see. Let's check with the answer given. Yeah, that is the longest. So subsequence. First, one thing that we need to see subsequence and subarray. These are both different. Subarray is continuous. Subsequence is non-continuous. Okay. So here the elements need not to be continuous, and we have to find the longest and common in both. See, 3 is common, but we can't consider 3, because if we consider 3, we'll get the longest as 2 elements only. As we have to find the longest, we have to uh, consider all the starting points, and we have to find the optimal solution, right? Okay. So let's think about it. Hmm. We can do this. If let's take I in array 1, the pointer, and j in array 2. So at any I comma j, if array 1 of I is equal to array 2 of j, then we got one element, right? Yeah. I mean, one element will be added to the answer. One will be added to the answer. If they are not equal, we have to take the maximum of I plus 1 comma j and I comma j plus 1. And this we considered I comma j, so we have to take I plus 1 comma j plus 1. 1 plus I plus 1 comma j plus 1. The maximum of these three is the answer, right? Yeah. So, what so let us write the DP state. What is the DP state here? DP of I comma j equal to longest subsequence from I comma j to n comma m. Okay, this is the DP state, and the transition equation is DP of I comma j equal to ma maximum of these three. If array 1 of I equal to array 2 of j, then 0, then 1, just 1, then 1, else 0, plus dp of I plus 1 comma j plus 1, and dp of I plus 1 comma j dp of I comma j plus 1. This is the transition equation. What are the base cases? Base cases. Okay, let's talk about base cases. I is I goes from 0 to n minus 1 and j goes from 0 to m minus 1, right? If I equal to n, then nothing can be the same. So if I equal to n, then for all dp of n comma j equal to 0 for all I, right? Because if one reach the end point of the array, the other can never match it. So for any index, if j reaches m, dp of I comma m equal to 0, similar argument. So here, these are the base cases. And yeah, what is the final subproblem? The final subproblem that we want to solve here is dp of 0 comma 0, right? Yeah. Let's now code this. Okay. Let's solve the time complexity. Let's talk about the time complexity. We have dp 2D dp array of n by m size. These are the number of states. And all these states, the time complexity is constant for every state calculation. So the time complexity will be number of states into time complexity for each state. So the number of states is big of n cross m, and the time complexity for each state is constant. So the overall time complexity is big of n cross m, where m is also of the constraints of n. So it is big of n squared complexity, which is acceptable. So let's code this. Let's Okay, we have to take n, m, and arrays input. Okay. N, comma, n, n, vector in array 1, comma. We are taking the input of the arrays. Okay. We've taken the input of the arrays. So now let's define the DP vector, DP table vector int DP 1 m plus 1 comma vector m m plus 1 comma 0. Okay. So base cases, as we kept 0, base cases were already there. For int I equal to n minus 1, I greater than or equal to uh, 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 hmm, 0 I minus minus in j equal to m minus 1 j greater than j minus minus dp of I j equal to maximum of dp of I plus 1 comma g dp of I comma g plus 1 dp of I comma j equal to maximum of dp of I comma g array 1 of I equal to array 2 of g. Then 1 L0 plus dp of I plus 1 comma j plus 1. So the final answer would be dp of 0, 0. Okay, let's see these. Okay, we got a different answer. Oh, okay. We had to print the longest subsequence. Oh, okay. We don't have to see the size. We have to print it as well. My bad. Okay. We got the size correct. Okay, but we need the longest subsequence as well. Hmm. Okay, now this is an interesting one to solve. Hmm. Yeah, we can backtrack if you want to get the answer. So let's see how we can do that, how we can get the answer back. So the subsequence that, just a minute, let me think. Hmm. For I from I comma j, we are either considering I plus 1 comma j or I comma j plus 1 or this I plus 1 comma j plus 1. Right. So if we have considered this, that means we're coming from the back actually, right? From here, we're starting here and then ding, 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 ding. We're going like this, right? So, we want the answer here. Let's see how are we getting the answer here. We're taking the maximum of these three here. Maximum of these three. Huh. Here, if the maximum of these three is this one, we would only have to traverse this state now, right? Whenever the maximum, which one of these three is the answer, we have to traverse only that to find the answer because the answer is coming from that state only, right? So let's see what of that is the answer. And we go to that state, and from that state, we see from which we are getting the answer. So from that, we can get the answer. And in that state, if array 1 of I is same as the array 2 of j, then that will be added to the answer, right? Okay, let's take an example in case that is unclear. For suppose the array is 1, 2, 1, 3 and 1, 2, 1, 3, 2. Okay. And the other array is 1, 3, 2 and 1. So here in this case, the here in this case, what is happening first? Uh, okay, n here is 1, 2, 3, 4, 5. M here is 4, right? So the DP array would be of 6 by 5 array. Okay, this would be the DP. And here the base cases are when n equal to 5 and m equal 4 here. So all these would be 0 as we have defined. And here the answer would be the maximum of this, and this. These two are not equal, so the answer would be 0 only. And coming to here, this maximum of these three. So I equal to 0, 1, 2, 4 and j equal to 3. So I equal to 4, j equal to 3. I equal to 0, 1, 2, 3. I equal to 4. First, this I we are considering and j equal to 2. Yeah, this is same. So the answer would be 1. And then the answer of this part. For this, the answer will be 1. And for this part, the answer would again be 1 because the maximum of these three. And then let's shift the I. Now the I is 3. So the second pointer would be traversing this array. So these are not same. So when they are not same, we take the maximum of these three, right? As they are not same, this would be 0. And then 3, 2. Similarly, let's fill the entire table once. 3, 2. This would be 1. And then this would be 3, 3. This would be 2. And 3, 1. That would be 2. So similarly, we can fill that and we can backtrack it to get the answer. Let's code this now. J equal to 0. Okay, fine. I less than n and j less than m if dp of I comma j equal to dp of I plus 1 comma j, then I plus continue. Okay, and let's define an answer vector. Vector in answer. Okay, then if dp of I g is equal to dp of I j plus 1, then let's do j plus plus and continue. Arrays answer dot pushback array 1 of I plus plus and j plus plus. Hmm. Where auto and so not a okay. Oh, okay. Yeah, we're good to go. Let's submit. Yeah, we completed. Good. So now the next question is rectangular cutting, which I already done. But let's do again because that was 1 year back. So and I also had many wrong submissions. That means I tried many approaches, maybe, or I might have checked the solution. So let's do this now. Given a rectangle, your task is to cut it into squares. On each move, you can select a rectangle and cut it into two rectangles in such a way that all the side lengths remain same. What? We have to take a rectangle. Okay. And we have to cut it into two squares. Squares. Oh, cut it into squares, not two. On each move, you can select a rectangle and cut it into two rectangles in such a way that all the lengths remain integers. What is the minimum number of moves? Okay, okay. What is the minimum number of moves? Interesting. A and B are of five. A and B are 500, right? So the problem now we are solving is rectangle cutting. So we're given A and B, and in one step we can cut it into two rectangles. Minimum steps needed to cut it into all squares. Okay, this is the question. So let's think how we can solve this. And in we are 500. So the time complexity can be big of A into B. It's 25,0,0,0,0. That can be into A. 25 into 125 into 10 power 6. Hmm. 125 into 10 power 6 into 8. But that would be strict bound. A square B would be very strict bound. So let's see. We can either cut it like this or this. Or there are many ways to cut it actually. Hmm. There are many ways. We have to find the number of minimum ways. We can either cut this part, this. We can cut it in any way. And similarly here also. We can do any number of cuts. I mean, we can do cut anywhere. What do we do now? dp of n comma m is minimum of 1 plus dp of n minus 1 comma m of n minus 2 comma. Okay, minimum of all these before. Hmm, interesting. Interesting. Comma dp of n m minus 1 dp of n m minus 2. Minimum of all these. Wait. Mhm. If you want to find here, we have to find the minimum of all these things and all these things. Okay, try. This would be minimum of all these again. And this would be minimum of all this. No, not necessarily. This would be minimum of all these and all these. So if these are minimum than that, that will be considered here. If this is minimum, we can just consider this part. Minimum of these two. We can just consider minimum of these two. Then we will be fine. Yeah. Let's code this. Let's take the input. Input is just two numbers. Okay. And now vector and 2D DP that would be. Wait. One important thing while solving any DP problem is defining the DP state, transition equations, base cases, and the final objective. I've just written the transition equation here nicely. What is the DP state? What does DP n comma n? DP of I comma j means minimum steps needed for I cross j rectangle, right? And base case. Base case is if I equal to j, then dp of I comma j would be 0, right? Yeah, yeah. Yeah, that is that. Just that. Mm. Hmm. One more thing. Here we have to add these both now. dp of 2 comma m plus dp of 1 comma m. We forgot this dp of n comma 1. Right. Hmm. Yeah. So, 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 so the state would be for n comma m, we would need n minus 1 comma m and 1 comma m. These two, it's actually the summation. Hmm. Okay. For every state, we would need n plus m. This is a strict bound. Okay, but we can do that. We need just n plus m. That shouldn't be n plus m can be 1,000 into 1,000. That would become 25 into 10 power 4 into 1,000. 10 power 7, 25 into 10 power 7. That should be fine. 10 power 8 2 into 10 power 8 into 10 power 7. This is, but that should be fine. Yeah, let's, so let's take in mind Let's take 8 plus 1. I equal to 0. In I plus this in J equal to 0. J was the number J plus if I equal to 0 or J equal to 0 or this is B. Uh, I is same as J, then the dp of I comma J is 0, right? And then 1 minute, else dp of I comma J p of comma J. So there is a long process for this. For in hmm, hmm. We can fix I and yeah. So this is the equation. Now, what is the final problem that we're solution dp of a comma? Let's check. That should work, but this didn't. Array, yaar. 1 minute. You have to add one. Na? Yeah, work. Let's submit. Rectangle. Yeah, okay. Very fast. This problem is not solved because this was really very complex and I've seen the solution in the morning. I'll solve it later on my own. I'll try to get to the solution on my own as well. We have solved this. Let's solve this. This is also a new problem. Okay, I'm excited to solve this now. You're given an n by n grid whose each square contains a letter. You should move from the upper left square to the lower right square. You can only move right or down. What is the lexicographically minimum string you can construct? Okay, so yeah, what's the question? We are given an array. We are given an n by n grid, and each element of the grid contains a letter, and we can either move right or down. We can either move right or down. We have to go from top left to bottom right, and we have to find out the lexicographically minimum string. Okay, okay. Lexicographically minimum string. This seems quite tricky because we have to find the lexicographically minimum string. For finding minimum string, mm, give me a minute, let me think. We have to store the entire string, but storing entire string is costly. Uh, I'm muting my mic now because I need some time to think about this problem. I'll unmute it later once I get an idea, okay? Yeah. Oh, by the way, it was off all this time. Oh, okay. Oh, wait, it is not off. How is that so? I'm not sure. Wait, it is not off. How is that so? Not sure. Wait, it is not off. How is that so? Wait, back to the question. We had to find the lexicographically minimum string. Money sums and renewal gain. Okay, just a minute. Let's see the problems because my brain is not braining right now. Minimum grade part, money subs. And all these are the new problems that I haven't even solved once. So today our goal is to complete this counting towers and minimal grid. Just solving these two is enough for today. Let's not keep what unrealistic goals. Yeah, this is my last problem for today. Minimal grid path. See the submission rates. This is actually quite tricky. See the submission rates. Only 5220 people have solved out of 9071. So it's okay. Let's try this. Whose square contains a letter. What are the constraints? N is of 3000. N is 3000, right? So we can go. What is the time limit? Time limit is 1 second again. So as time limit is 1 second, we can do 10 power 8 operations. So we can go until n square log n time complexity. So as n square log n time complexity. And the space complexity, can we store a string everywhere? If we can store a string that, then this question would be pretty easy. But I'm not sure we will be able to store such many strings. Let's let's anyway try coding this. Then only I'll get to understand what's the problem. Mm. Why does this fail? Oh, yeah. It could be something maximum. What is the maximum and strength? मुझे एक और असाइनमेंट दिखा उसको मेल आज नहीं देता बस एएम में let's try this. Yes, पर इसके लिंक है नहीं है नहीं है सही है क्या let's try these cases differently. Yep. This should work fine. Okay. Why is my internet not working? Array. Why is my Wi-Fi not working? Oh, I can't disconnect with the Wi-Fi because the stream will be what is it? Disrupted, whatever. Hmm, just a minute. Okay, this is not working, so I am stopping the stream.